Hey everybody, welcome back to the channel and welcome to my new series called Beginner CNC and Laser Projects That Sell. In this series, I'm going to take you through CNC and laser projects that beginners can make that actually sell. We'll be working from start to finish, showing every step in the process, from design to creation. And I'm also going to be uploading the files for free in the description below. So you can create these projects for yourself for fun, for family, or even maybe to sell. If you're new to CNCs or lasers, or just interested in the process, this is going to be for you. In this video, we're going to be creating a wooden address sign using the Shapeoko 5 Pro CNC. Using Carbide Crate, I'm going to take you through the design process of this file. We're also going to be talking about work holding, flattening, pocketing, chamfering, and contour toolpaths. I'm also going to show you how I stained the project and finished it. So first things first, let's get into the design. All right, so here we are in Carbide Create, and here is our design. This is the address sign. If we go into the Toolpaths tab up here, we can go ahead and simulate this to show you what this is going to look like. So we just have a simple rectangle with a pocket toolpath in the middle, which exposes the raised letters. We have some tabs in here, and we also have a chamfer around the edge. So now that I've showed you what we're going to make, let's go ahead and design it. So before we start designing anything, let's go ahead and go to our project setup. I like to do this first before we do anything. So we're going to set up our stock size. My piece of wood that I'm going to be using for this project is 16 inches wide, and it's 7 1/8 tall in height. It's 1 inch thick. We have our 0 set to the top. We have our toolpath 0 set to the bottom left corner. This is almost always where I set my toolpaths. Material, I'll just go ahead and put hardwood. We have the Shapeoko 5 Pro. Our retract height is going to be 0.3 inches, and that all looks good. So design-wise, the first thing we're going to do is we're going to create a rectangle. I'm going to use the rectangle tool and draw a rectangle that is 14 inches wide by 6 inches tall. And I'm going to center that on our work area. So this is the outside perimeter of our sign. You could see that it is well within our piece of stock that we're using, and that is so I'm able to clamp around the outside of my piece without it interfering with any of these cuts here, this perimeter cut. I'll show you that later when we go to set up the actual piece on the workbed. So we have our rectangle. We want to make this interior rectangle here because this is going to be our pocket. It's kind of like a border around the whole sign. So we're going to click on our rectangle. We're going to go over here to the offset tool, the offset vector tool. We're going to click on that. And we want to create an offset that's 3/4 of an inch to the inside. We're going to apply this, and boom, that's going to draw another rectangle 3/4 of an inch inward from the original rectangle that we drew. And next thing we got to do are our numbers here. So we're going to go to the text tool, and we're going to type in our address. So obviously this isn't the right size, so you can either change the size in here in the font height section of the text window, or since that's now too big, we can go ahead and click on the scale button here, and we can just scale it this way if we would like. Or you can actually type in here the size that you want it. Let's say I wanted it 10 inches wide, and it scales proportionately. So let's go ahead and make this a little bit smaller. Going back to the text, also you can change your font here. Any custom font that you load on your computer will actually populate into this menu. I'm going to pick Century Gothic. So now we want to center this in our rectangle. I'm going to hold down Shift, and I'm going to highlight the inside rectangle. So now both of these are highlighted. I'm going to go to our Align Vectors tab. I'm going to align this both horizontally and vertically. And really, that's the majority of the design work we're doing on this beginner project. And lastly here, we are going to add some tabs to our outside perimeter. So we want to make sure that our outside vector is selected, and we're going to go down here to the menu to the Edit Tabs button, and then we are just going to add tabs on the outside of our project. For this, I just like to do 4. So that is the design. Now let's go ahead and assign toolpaths to all of these vectors here. So next, we're going to go into the Toolpath menu. I already have my toolpath set up over here for our original file. So what I'm going to do is I'm just going to go ahead and disable all of these, and I'm going to add another group. Okay, so the first toolpath we're going to create is our pocket. So I'm going to click on our inner rectangle and our numbers, highlight those, and I'm going to click on the pocket toolpath. We're going to use current selection, and I'm going to edit our tool here. We are going to use a 201 end mill. That's the end mill that comes with your Shapeoko. It's a 1/4 inch down cut. We're going to select that. We're going to leave our tool parameters just stock, because for beginner projects, I do like to just leave these at the stock setting. As you become more comfortable, feel free to go ahead and up these speeds or to change them as you desire. But for right now, we're just going to leave them stock because they do a great job in the stock settings. And our start depth is going to be the top of the material. Our max depth is going to be 0.15 inches. We're going to call this our number pocket. And as you can see, our toolpath is generated here. If we go to simulation, we can see now we have a pocket cut in the middle of the wood in our rectangle, and our numbers are now raised. Okay, so one thing to note here is you'll see in the numbers, you're going to have some rounded areas like this. So this is a little bit rounded because we're using a 1/4 inch end mill to pocket out this material. So that's the shape of the bit. That's the shape of the end mill. That can't quite get into this inside corner here. So what you can do is you could use an 1/8 inch end mill, and that would create a smaller semicircle here because the bit is only 1/8 of an inch in diameter. But it's going to take a lot longer to create this pocket with an 1/8 inch end mill. Let me show you what that looks like now. So if we change our tool to a number 102 1/8 inch, you can see our tool path is now changed. We're going to simulate this. We're now at 94 minutes to do this pocket. We have a little bit better crispness to our numbers, but it's still got, you know, a little bit of a round feature there. But 94 minutes is just way too long. I don't think it really looks that much better, really. So we're going to go ahead and change this back to a 1/4 inch. In Carbide Create Pro, they have a feature that is called rest machining. And that's really neat because what it'll allow you to do is to use a 1/4 inch end mill for the majority of this pocket. But then you can select just these areas here where you need to get in a little bit tighter, and you can machine these with an 1/8 inch or a 1/16 inch end mill, but it's only going to use that smaller tool just where it needs it here, so it saves a ton of time. But that is a feature in the Pro version, which I do not have, and in this case, I think it looks just fine. I'm okay with that design, so we're going to leave it the way it is. The next thing we're going to do is we're going to create a finishing toolpath. So we're cutting down 0.15 inches into our stock to create this pocket. So sometimes that'll leave a little bit of a rough pocket in the bottom, which requires a little bit of sanding, and that's never fun to do when you have, you know, all these little spaces to get around. You're trying to go around all these numbers. It's kind of a pain in the butt. So we're going to go ahead and I'm going to duplicate our toolpath here, and I'm going to call this number pocket finishing pass. We're going to edit our toolpath, and we are going to start our depth at 0.15, and we're going to finish our max depth at 0.16. So we're only going down 1/100th of an inch. Next thing I'm going to do is edit our tool settings. We're going to keep the 1/4 inch end mill, but I'm going to turn the step over down to 0.1. I'm going to leave depth per pass because we're only going down 0.01, so it's going to do this in one pass. We're going to change our feed rate to 125. That's pretty fast, but we're only taking off that little sliver here so it can handle it. So you can see if I disable our main toolpath here, here's our finishing pass. These lines here are a little bit tighter because we changed our step over. That's going to create just a little bit cleaner of a cut by stepping over 0.1 instead of 0.12 like we were doing before. I'm going to go ahead and re-enable our first pocket toolpath. Okay, so now we are done with these two. We have our pocket and our finishing pass on our pocket. Next thing we're going to do is we are going to create a chamfer around this. So we're going to click on our outside border. We're going to go to toolpaths. We're going to press contour. I'm going to change my tool to a 90-degree V-bit. I'm going to leave the settings stock here, stock hardwood settings. But our max depth, I'm going to only put 0.1. And we are going to cut on our line. So we're going to cut with no offset. You can see that moved our blue line directly onto our vector here. If we click on outside right, it's going to cut on the outside. If we cut on the inside, obviously it's going to move to the inside. We don't want that. We want to do no offset. We want this to be the same size rectangle that we originally set it as. We want to cut right on that line 0.1 inches, a tenth of an inch, and that's going to give us our chamfer. We are also going to want to make sure we click on ignore tabs. If we don't, the V-bit is going to skip everywhere we put those tabs on here. So this will create one continuous border outline with the V-bit, and we'll go ahead and change this toolpath to chamfer. So we'll simulate this. You can see we have our pocket and also this small little chamfer around the border. Now I like to add our chamfer at this stage because our entire workpiece is supported really well at this point. Our main piece of wood is going to be clamped down to the table. You know, we've only pocketed just a shallow amount in the middle here, so our board is fully stable. One thing that you could do is you can create your contour cut around the outside perimeter and leave your tabs in place. But then when you come back to do this chamfer toolpath, you only have those tabs supporting the piece. So you're running the risk of the part actually breaking out and coming loose, ruining your part. So I do like to do the chamfer at this point. I think it's worth doing at this point, even though it's an extra tool change that you have to do, just for stability purposes. So the last toolpath we're going to be creating is our cutout, our contour cutout. So we're going to click on our outside border again, click on contour, use current selection. We're going to keep our 201 end mill. This time though, we're going to start at the top, but we're going to cut down all the way through. So we're going to go 1 inch, and we want to make sure we go all the way through. So we're going to go down about 0.02 of an inch, so 1.02. We're going to have our offset direction set to outside right. This is going to cut again on the outside of our line here, so that this piece will be a true 14 inches wide by 6 inches tall. We're going to call this our perimeter cutout. And if we look at our simulation, here is our completed part. And you can see our tabs holding this in place, our pocket, and our chamfer. So that's it. We've gone ahead and recreated all the toolpaths for our sign. We're pretty much ready to go. There's one more bonus toolpath that I'm going to throw in here. Now you might have noticed this other rectangle that I had down here. So what this is going to represent is a flattening toolpath. One of the great things about the CNC is it gives you the ability to actually flatten stock in much of the same way that you would use a jointer and planer combination in order to get some flat pieces of material. So what I've gone ahead and done is created a rectangle, and I'm going to change that size to just about 1/4 inch bigger than my stock. Now I'm going to create another toolpath. I'm going to do a pocket. I'm going to change my tool to my flattening bit that I have. It is a 1.5 inch surfacing bit. I'm going to leave these parameters the same, and I'm going to rename this flattening. I'm going to have my start depth be at the top, and I'm just going to go down 0.005, 0.005 of an inch. I'm going to call this flattening. All right, so I'm going to disable my other toolpaths here. So this isn't mandatory, but if you want to make sure your stock is perfectly flat, you can run this flattening toolpath over the front side and the back side of your stock before you do anything else, before you run any of these other toolpaths. So I put this at the top. In my video explanation that we're going to do next, I'm going to show you how to do this if you want to, how to secure your piece during the flattening setup, and then how to secure your piece during the other toolpaths. This is not mandatory, but it is a nice little tip to know. Having your material perfectly flat will help out when you go to pocket out these numbers so there's no high and low spots. This is really important, especially when you're doing stars or V carving in general. If your stock is not flat, if there's highs and lows, dips and valleys in it, you'll notice that on your V-carve. They won't be totally consistent. So having a nice flat surface is going to help alleviate that. In this case, it's probably not too important because you're not really going to notice slight variations in the height of this pocket here. But like I said, it's a good tip to know. So that's why I'm going to explain it in the demo coming up next. And I will have this flattening toolpath included in the free file that you can download. But what I'm going to do is I'm just going to leave it disabled like I have here in my list of toolpaths. If you'd like to use it, just go ahead and enable and disable the other ones first. All right, so let's get this saved and throw it on the CNC and get it cut. All right, so here's our stock for the project. This is a piece of, I believe it's red oak. I'm not sure exactly. It's some sort of oak. but it'll be good for outdoors, so it's going to be good for this little address sign here. But we're going to start out with an example of how to do the flattening pass on this. So I'm going to have two different types of work holding for this project. The first is I'm going to be applying sideways pressure to this board because I'm going to be surfacing the entirety of this board and I don't want anything to get hit. So let me bring you in closer. I'm going to show you how I'm going to secure this to the CNC. So I'm going to use the bottom left corner of my CNC to run this job. And you can see here I have these 3D printed dogs that go in these holes on my wasteboard. So this is going to create a bottom fence for this board to be held against. On the left side here, in the track, I just have some of these square stops from Carbide 3D, which is going to give me a stopping point here on the left side. If you're interested in this wasteboard design, make sure you check out my other video. I explain it in detail and also give out the file so you can make this for yourself. Okay, so now that our piece of wood is up against the fence, it's not going to move down and it's not going to move to the left. We need to make sure we put pressure on it in both of those directions so that way it doesn't move. So to do that, we're going to use these Crush It clamps by Carbide 3D. And this is just a clamp that is secured down to the wasteboard and it pushes forward on the material. So I'm going to be pushing it this way to the left, and I'm also going to be pushing it down towards me up against these dogs, and that's what's going to hold it in place. Let me show you how these go together. So on the right side, I'm going to secure this down to the threaded inserts that I have in my wasteboard. And this is another reason why I really like this wasteboard design, because if I just had the stock slats in here, you know, this piece can only go into the T-track in that example. And in this particular case, my T-track is so close to the right side of my board that I'm not going to be able to get I'm just not going to be able to attach it that way. So I have these other two holes here along the entirety of all of my slats here that gives me other clamping options. So I'm going to place it in this threaded insert location and screw it down like so. As you tighten this screw here, it's actually going to put force to the left, and that's going to put pressure against the stops that I have on the left side. So I'm just going to tighten this a little bit, just put a little bit of pressure here. The next thing I'm going to do is I'm going to put two more clamps up at the top to press down. So let's go ahead and put two more in at the top. Now this piece is secure. It is not going anywhere. And these clamps are low enough below the surface of the wood that our surfacing bit can cover this entire piece without hitting anything. All right, so before we switch to our flattening bit, and I'm going to be using a 1.5 inch flattening bit from IDC Woodcraft. I'll leave it in the description below if you're interested in picking this up. I'm going to set my X and Y 0 at this point because right now I have a 1/4 inch end mill installed in the spindle. It'll make it a lot easier to do that at this point. So in this example, to set 0, I'm going to do this manually. Now Carbide 3D does sell a probe, an XYZ touch probe that will help you set your X and Y and Z zeros, but you can also do it manually and it's not that hard. So just in case you don't have that, I'm going to show you the old-fashioned way how to do it. So we have our material down on the bed. We're just going to jog our machine and we're going to eyeball it to where it's exactly on this bottom left corner because that is our origin of the job. And that looks pretty good right there. Remember, this design, it's not critical that you get the X and Y 0 point just dead on, because going back to when we designed the file, we made our stock large enough and our project small enough to fit inside of that stock. So we leave room for the clamps and we leave room for small amounts of air in the XY. So that's why I always like to keep my stock a little bit oversized and my projects just a little bit smaller, again, for clamping. And it also helps setting the X and Y, so you don't have to be so precise. Other situations, that's really, really important. In this case, it's not. So now that we have the X and Y zeroed out, let's go ahead and switch over to our surfacing bit. So when you're using a surfacing bit to, say, surface your entire wasteboard, it's really important to turn off your bit setter and also remove it from the machine. That way the surfacing bit does not come in contact with it. In this case, my material is so far off on the opposite end of the bed, I'm still going to disable it because I'm going to set the Z0 point manually, but I don't need to actually take it off of the machine because I'm not getting anywhere close to it. So to manually set our Z height, what we're gonna do is I've jogged our machine over to our work area. I'm gonna lower the bit down and use just a regular piece of copy paper here. And I'm gonna lower the bit down and move my piece of paper just to see where it barely kisses the paper and I start to feel some tension. That's where I'm gonna set my 0 point. Okay, and I'm getting pretty close, so I'm gonna switch my jog settings down to 0.01 and I'm gonna continue going down. And there we go, now I'm touching. Just barely touching. That is where I'm gonna set my Z0. All right, so finally, before we run this flattening file, what I wanna do is just take a pencil and draw some squiggly lines over the top surface of my piece of wood. So that way I know that my flattening bit has actually touched every surface on top of the wood. If after one pass, I look at my piece of wood and not all of the pencil mark has been erased, I'm gonna go ahead and reset my 0 down and run the file again. I'm gonna do that as many times as I need to in order to flatten this piece out. I do anticipate though that this piece is already pretty flat. It should just take 1 or 2 passes. All right, now the top of our board is nice and flat. All our pencil marks are removed. Now what we got to do is unclamp this, flip it over, and do this one more time so both the top and the bottom are flat. All right, so there we have it. Our board is nice and flat, and we're ready to move on to the next steps. So while I have this clamped up to the CNC, I'm gonna go ahead and sand it up to 120 grit. And then I'm gonna apply some black stain to the entire board. Now, I'm doing this because I want the border to be black and I also want the numbers to be black. So I'll stain the entire surface black. The router will pocket out the material, so I'll have a nice two-toned effect. Now, this is just regular Minwax gel stain. I do like to use the gel stain because it does not run as much as the watery, water-based stuff does. So let's go ahead and get this thing sanded and stained up and move on to the next step. We're now ready to go ahead and actually run the project. So I've loaded the file into Carbide Motion, reset my Z-axis 0. To start off, I have the number 201 1/4" downcut end mill installed. Okay, so real quick before we start. So right now I'm using the Crush It clamps to apply side force to both my stops on the X and Y axis. And this is a really good stable clamping platform. Just in case you don't have these clamps, I'm gonna change the clamping setup here. I'm gonna use the regular essential clamps that come with the machine, and I'm gonna install these on top of the material in order to place clamping force downward. And that's really gonna lock this piece in. It's a second option. And since my file is smaller and it fits within my stock here with some good room on the outside, I'm able to use these clamps without any fear of them being hit. As we're watching the CNC run, remember, if you're liking this video so far, please give it a thumbs up. And if you haven't already, please consider subscribing so you don't miss out on anything. So before I do the next tool change, I'm going to insert the 90-degree V bit to do the chamfer. I just want to bring you in close here and show you how clean of a cut this leaves where I pocketed out the material. Doing that second finishing pass really makes a big difference. Now, what also makes a really big difference is using the 1/4" upcut bit. So you'll notice that there's some fuzzies on the top of the material because an upcut bit pulls the wood fibers up. Now, that leaves a little bit of a rough finish on the top of the material, but it leaves the bottom of the material very smooth. So in this case, I chose to use the upcut bit in order to limit the amount of post-processing or sanding that we're going to need to do inside this pocket. And I'll show you how we're going to deal with those fuzzies on the top in a minute. Let's go ahead and put in the 90-degree V bit and run the chamfer toolpath. And lastly, let's get this thing out of the clamps and get those tabs cut. Okay, we're almost done. We're gonna take a random orbital sander and smooth out these edges, take off some of those remaining tab bits that we got here, throw a coat of finish on it. So what do you think? Pretty easy, right? I love this simple beginner CNC project, and I've sold dozens of them without even trying, just word of mouth. Now, I'm not saying you're gonna be rich off this idea or anything like that, but I know it's a solid product, and if someone's got a house, it's a perfect gift for them. If you have any questions, you want me to explain something in more detail, or you just wanna say what's up, make sure you leave a comment down below. I'd love to hear from you. And hey, let me know if there's a CNC or laser project that you'd like to see me do, and maybe we can add it in the series in the future. Thanks a lot for watching. See you on the next one.